Welcome back, everyone. Today we're going to be looking at the traveling salesman. So I just did a really basic one that allows the user to either just call the program itself, and it has some defaults. So I have some random points, and so these would be stops on this traveling salesman's journey. Now when I close this graph, it automatically finds the nearest neighbor method, which means it starts at one of these points, whichever one happened to be the beginning. It looks for the next nearest neighbor, and without going back to any other stop that you've already gone to, it'll find then the next nearest, and then the next one, and the next one of all the remaining stops until you get back to until you're out, and then you're back at the beginning. Now, the default is 10 points from 0 to 10 on the X and the Y axis. Now, if I want to say do 100, then I can just add 100 data points. We can just simply add that. You can see there's a lot more now. And then now we can see that it has found the nearest neighbor. Now you see some crossing, and you can do some more optimization. One with traveling salesman, and I'll talk about that more when we get into the code. But you can also do stuff called opt2 and opt3. I do plan on doing a video on those coming up. But for now, this is what the nearest neighbor, how that will get you more optimized than the just straight random traveling path. Now let's say I want to go negative 100 to 100. So I'll get data points between that range. Now we can see here on our X and our Y axis that we've got a much wider range. And again, I can click that, and it gives us a much more optimized path. However, we still have crossing, so it's not the most optimized. So if we start looking at the code, this is in Python. And we're actually going to start at the bottom. So all those were functions. When I call the program, if I don't have anything other than just the name of the program, then the argument, the argv, or the argument variable array, will only have a size of 1, which means then I'll call my display graphs function with 10 as the data point size, how many data points I want, and the range from 0 to 10. Else, if it's the size is equal to 2, which is where we get length of the argv array, then we'll pass that that number in, and then again we have a default from 0 to 10. And if we want to adjust all of it, then we just give it the different data points, or parameters, I mean. So we give them 3 parameters plus the program, and then it gives us that variability. So let's go to display graphs. So we have parameters of num of stops, min, max. It's going to return nothing, but it will display our original random graph, and then when that's closed, it'll display our nearest neighbor graph. So we're using the PLT, and we get that from matplotlib. And actually, we're not using this. That's for a different project coming up. We've got random, we've got math, and we've got sys. And sys is how we are able to get the argv parameter array. So with PLT, this is going to be how we show the graph. Dot title, we can give it a title. It will need the X and the Y values. So I have set here that we have an XY random 2D array. And so we're going to call get random original path, pass in the number of stops, the min, and the max. So it's a 2D array, which means it's an array of arrays. So xy is actually of size 2. There's a 0 and there's a 1 index. The 0 index will be an array of all the x coordinates, and 1 will be all of the y coordinates. And then we'll just do PLT show, which will actually show that graph. It'll wait until we close the other one. We close it, and it does the exact same thing. However, this time we use those data points in here for nearest neighbor. We get a new x and y 2D array. And again, our 0 and our 1, 0 and 1 indexes will be our x and our y coordinates, and then we show it. So to start out, we will go look at the get random original path. So again, it takes a number of stops, min and max. We have 2 empty arrays. We have our temp x and our temp y. We are going to cycle through the range of number of stops. So let's say this was 10, it's going to cycle through 10 times. We take temp x and temp y. We append a random number in the range of the min and the max. We then append the same the first index so that it makes a loop, and we return an array of temp x and temp y, which gives us our index 0 of our x values and our index 1 of our y values. To get the nearest neighbor, we pass in this type of an array, or the result of that. That's what it takes as a parameter. We have result x and y, which is, if we look down here, we're going to return that. So we start out with the first index of our xy list. So again, our first x value, our first y value, and then we're going to pop that from the list. Because now we've added it, we don't need to go over that again. We're going to hold the last, which is really just going to be that same value, the first value. But since we added it on the last, we're going to add it here. So we take the x value from the xy list. We're going to find the length of the xy list 0 minus 1 to give us that last index. We're going to do the same thing for the y. So we're going to hold those values in here. And then we're going to pop off that last index from the list. So now all we have is all of the data points in the middle of our start and finish, which was the same point. But we've held this so we can add that at the end. So now we're going to do a while loop. So as long as the length of our xy list, and we're just going to pick the first one because we're going to do the same thing to both 0 and 1. So those links will always be in sync. So as long as there's at least, there has to be more than one data point in our list, then we're going to cycle through and find the next nearest neighbor. So we start off with saying the smallest distance is none, or a null, could be also considered a null value. Although in Python, nulls don't exist, it's just called none. We have the smallest distance index. Then we're going to cycle through the range to the length of our data points. So we're cycling through it here, but then we're going to cycle through, for each one, we're going to cycle through the rest of them as well. The temp distance is going to equal the distance between the last point we added in the result, x and y. So this is going to be the x value right here. This is going to be the y value, again, of the last one that was added to our result set. And this will be the given index because of this I that we're trying to find in the rest of the array, the rest of the unprocessed array of the xy list. If the smallest distance is equal to none, which means we haven't added anything into it yet, or the temp distance is less than the small distance, so in that case we've already added a distance, but we found one that's smaller, then we will set the smallest distance to be that temp distance, and we'll set the smallest distance index, so where's that data point, which index is it, we're going to set that here in the smallest distance index. Once it's cycled through all of them, we now know we have found the smallest distance, smallest next distance. We go to the result x and the result y. We append that point by getting the smallest distance index. So again, we get our x and we get our y, and this number will be the same. It's the same index. And then we will pop it from the list, so we don't go back to that point again. So we pop it from the x and the y, again, using that smallest distance index. Once we've gone through all of that, we've now popped out of the while loop. We only will have one data point left. We're going to append it because it's now going to be index 0. Then we append the temp last x and y, which again we did up here. We held on to that. And we can now return a new xy array that is now been processed to be the nearest neighbor. To get the distance between the points, we give it 4 parameters, x1, y1, x2, y2. So this would be one coordinate, this would be another coordinate, and this is the calculation or the algorithm to figure out the distance between 2 points. I just looked that up and put it in here. So we've got x2 minus x1 squared, that'll be all that, plus y2 minus y1 squared. We take the square root of all of that, and that will be our distance. And that is what we use right here. Again, all of those get called here and here, and that is how we show the plots on the graph. There'll be more to come on this, but this is a really cool exercise. This was inspired kind of with a capstone project I did in college where we were looking at travel planning application for flights. So you can create an itinerary, and then the program would figure out the shortest path to get to all of the different destinations. Feel free to have fun with this and see where you take it. Thanks.